back to Engineer's Workshop, and welcome to part 2 of how to ruin a Bosch injection pump. Hopefully not. So what we're doing is we are trying to bore out a cavity in here that houses the pressure relief valve, which got stripped due to trying to remove this. And we've got set up in the vise with a custom fixture plate, using one of my parallels to tram this, trying to get within maybe a couple thousandths or a thousandths over 3 or 4 inches. And I'm coming downhill right now, so I need to tap upwards on this. That's looking pretty good side to side. I'm thankful that I'm good in the Y direction, but I still want to get some something to support the back end of this and clamp it down a bit back here so that it doesn't vibrate or ring while I'm milling it. Leveled across the top, front to back, and we're going to zero in on this bore here and continue on trying to bore out this cavity. So let's proceed where we left off. Okay, I blew this little valve way up so that you could see the geometry of the complicated hole. So we've got an O-ring at the top, and the O-ring is 60 thousandths from, let's call it the top surface where this cap seats. So down a 1/16 of an inch. The bottom O-ring is down at 0.965, so almost an inch down from the top. The bottom O-ring diameter is 0.465. That's uncompressed. The top O-ring diameter is 0.605, uncompressed. The hole at this point, these surfaces right here, best I could tell is 0.5675. And the difference is 0.0375. And that's a squish of 0.01875 per side. The threads end 0.345 from that surface, and there's a port coming in from the side of that hole that basically comes in at about 0.466. So the length of my insert really only has to be about 0.345, or let's say 3/8 of an inch from there to the bottom. And it should not really exceed probably a 1/2 inch, or it's going to start closing off this port. So what I'm going to shoot for is an insert that has a body something like that. And that diameter gonna be around 3/4 of an inch to press into the aluminum body, and this is going to be steel. So that is what we're going to try to make. Then we're going to screw that insert onto the actual valve and use the bottom stem of that valve to help keep everything straight when we press or tap this guy home. Probably going to use some Loctite 648, is it 648? Which is a retaining compound for close fitting parts to seal that, and that is also oil resistant, so it should do okay with the diesel fuel. But we're going to shoot for a, I don't know, 1/2 thousandths to 1 thousandths interference fit on that insert. So let's get set up finding the center of that hole. Try not to get dizzy from this. I've got a nice beefy Bridgeport #2 boring head. Got this off eBay. Pretty sure this shank was turned down from something significantly bigger, but it fits what I've got. Maybe one day I'll square up this shoulder, center tap that, and make a sleeve that will, you know, hold that sleeve on in tension, and let this get alternately chucked into maybe 1.25" or even a 2" tool holder for use in the Rosenfors mill. But I'm going to put this in the machine, and I've got a C2 brazed carbide boring bar. Here's the boring bar I'll be using, nice and beefy. So we'll take light cuts and open up this bore. Before I start, I want to pack these passages with some paper towels to prevent chips from getting down in there. And a couple of final checks. The counterbore at the top is 790. So it kind of looks like 750 is a good target diameter for the insert. And what I can do is I've got a 750 gauge pin, so I can bore and keep checking it against that 750 gauge pin. When that just goes in, I'll stop, and then I can work the insert, the OD of the insert, down to 750, and 750 plus half thousandths or thousandths for a light press fit. Let me get the air compressor on, and next we got to set the depth of this hole. So I've set the quill stop so that it will stop short of the hole, and I've run it through a few cycles, and I've watched, and my vernier here, this is the manual quill feed, stops with the arm horizontal. I want consistency because I'm going to be boring this in several steps, and I don't want the, as I increase the offset of the boring bar, I don't want it to accidentally step over too far. It seems consistent. So what I'm going to do now, I've got my DRO zeroed. I'm going to pull this hole off center, and I'm going to manually raise the knee until the cutter is in contact with the top surface. And then I'll know, that's my reference point. I will raise the cutter head by the depth I want on that counter bore, which I believe is, let me check what that number is. The insert is going to be probably 0.375, and that secondary passage starts at about 0.466. So I might set up for about a 450 thousandths depth. So we're still coming up with the knee until I'm just going to graze that surface. I'm just starting to raise a chip. So that is, cutter is bottomed. I'm going to come back to 0 on my y-axis. Let's lock the X and Y tables. Now I'm going to raise the cutter. And the cool thing about the K&T, this is a manual machine. So this thing can be indexed every 2 thousandths. So I can come in here and zero that. And now I will come up 450 thousandths. $100, $200, $300, $400, and 50. First pass I'll do without an offset just to check things out as a dry run. Got about 625 RPM and 0.6 per revolution, less than 1,000ths per revolution. Okay, I'm going to dial in some offset that will hopefully clean out the threads. At least start removing material. It is working. Try another 5,000ths. So you can see we're taking out the threads, but we're not to the point where we're out to the diameter of that original O-ring landing is. Initial few passes, it didn't seem as smooth, and what I had happening was the back edge of this cutter was rubbing, so I had to take the nose and rotate it slightly in the head. Now that that hole is amazingly smooth, smoother than the original. So it's cutting so nicely. I'm going to try 15. Now I'm right at 600,000ths on the hole, and I am very pleased with the finish I'm getting. Is this that jig bore finish that Dee talks about when you're doing good with your boring head? See if I can get you in close on that. That is just a super nice finish. And this is with that Bridgeport #2 boring head, which I'm loving. A good setup, a sharp tool. This is C2 brazed carbide boring bar. So let's, I'm going to keep on opening this up to about 650 thousandths, and then I'm going to take the packing out and I'm going to recheck the center and see if we're still on target for the bottom of that hole. Let me show you what I mean. So basically I indicated this bore just a little bit below the top of the casting where that O-ring rode, and there was a smooth part of the bore before the thread started. So I zeroed on that, and that's where I've been doing my boring down to that depth. But down here where the bottom O-ring pilots, I'm going to reach down and I'm going to see if the center line here is the same as the center line here. And the reason why I suspect it might not be is just the way I see this bore going in and how much of the threads it was taken out, you know, on one side versus the other. There's no guarantee that this was all put in one operation. This could have been a multi-stage setup, or at very least a multi-tool setup, and you know, coming back to zero. So I want to make sure that when this goes in at the top, that this O-ring in the bottom is also centered. And I had to buy a long stem half thousandths indicator in order to reach down here and check it. But once I get out another 50 thousandths on this bore, I'm going to start. I'm going to set up to check this down here. Here's the indicator I bought off eBay. Has about an 1.5 inch long probe, half thousandths resolution. So I'm going to get this installed, reach down into that bore and sweep the polished bore that's down at the bottom that lower O-ring rides on, without moving my center point, which I have zeroed on the DRO. I'm going to see if that center of the hole is the same as what I set up for to bore. If it's not, I will make adjustments to the position to match down here before I've got, you know, that upper bore up out to its full diameter. On that last one, I went 15 thousandths. Could probably go more, but no point, I'm learning. Okay, I'm at 640, let's go 10 more, and then we'll pull out the packing and measure at the bottom of the hole. Let's see if I can get you in real close and see that bore. So we're just starting to encroach on that port on the side. Do I still have packing in there? I think I do. So I'm going to put the head back on zero, and then I'm going to reach down and indicate that smooth bore down there. So there's a sweep of the bore we just did. Good for, you know, within about a half thousandths. I'm pretty happy with that. Other than a few surface undulations, it looks like the bottom of that bore is concentric or on the same axis with the top of the bore. I just want to show you my setup here. Got my camera holder on one side of the boring head, and I've got the indicator on the other side. That works out pretty well. Well, I did a little bit of measuring, and best I could do with the calipers is I'm at 652. I'm going to try to use my little sliding parallels and measure that hole more accurately. Don't know if I have a combination that will work. Maybe if I stick a gauge block in there. Problem is you know, they start out at one measurement and they're perfectly flush end to end, but then you slide them apart to increase the width, and one projects down further. Now I've only got a ½ inch of good surface to measure against, so I'm gonna have to see if I'm right there at a sweet spot where I can get a measurement with two of those. So isn't it great that every now and then you get lucky? These are the Brown & Sharp sliding parallels that I have for measuring holes, and lo and behold, a C and an E together are like exactly right to measure that hole. These mics are reading a couple tenths high. So 652. Probably, 651.7 if you subtract what these are, but I'll check a couple more points and we'll target our insert for that diameter mics. But anyway, 652. If I go up to my next nominal size, which is 750, I have a gauge pin for 750. I can make my insert targeted for like 751, but I have two sizes of hex stock in that leaded material. I have like 1.125" and I have 750. And the 750 is like 751, 752 on the flats, so not a lot of wiggle room. But if I go ahead and I size the insert for 652, 653, I can try to do it as is. So that's what I'm going to do first. I'm going to leave this set up. No sense breaking it down. And I'm going to start working on making the first insert sized for 652 and see how that works out for this hole. So that's probably another good breaking point. We'll start working on the insert next. Wrap it up in part 3. And hope you enjoyed seeing this Bridgeport number 2 boring head in the K&T rotary head mill, boring a beautiful, beautiful hole in this aluminum casting. So stay tuned for the conclusion, probably next week. As always from Engineers Workshop, stay safe.